2 cosine squared, oh, that's not a squared, cosine 2x minus 9 cosine x plus 7 is equal to 0. Okay, so we have that same problem again. We have this 2x and this x. They're not the same argument, so that causes problems for my solving of this function. So I'm going to use an identity to change this term out. Which identity? I'm going to choose this one. Cosine 2x equals 2 cosine squared x minus 1. Why? It makes it so the argument is x, but also maintains the cosine. If that was like sine or tangent or whatever, then I have two trig functions instead of just one trig function, and I can't do algebra with that. When I have cosine and cosine squared, I can think of it as x squared and x and just do some algebra. So this is going to become 2 times 2 cosine squared x minus 1, substituting in right here, minus 9 cosine x plus 7 equals 0. I'm going to distribute the 2 and get 4 cosine squared x minus 2 minus 9 cosine x plus 7 equals 0. And then I'm going to combine like terms and get 4 cosine squared x. Subtract 2 from the 7, so nothing happens with this middle term. And then I get plus 5 over here. Now I'm going to be factoring by grouping. I'm going to take my 4, multiply it times my 5, and get 20. And then find factored pairs of 20 that add up to negative 9. Are there any? 1 and 20, 2 and 10, 3 and nothing, 4 and 5. Oh yeah, I guess it's 4 and 5. In fact, it's going to be negative 4 and negative 5. What a moron. That's right there in front of me. Don't laugh at me. All right, so 4 cosine squared x minus 4 cosine x minus 9 cosine x. Remember, these two numbers inform me how to split my middle term, which is a little different than quote normal factoring, inverse distribution, though this is similar, same. It's just this little extra step in here. It's actually exactly the backwards process. We don't skip anything. The other one's a shortcut. So now I'm going to group these two guys and factor something common from those two terms, and group these guys and factor something common. I made a mistake, right? You guys are already yelling at me, but I can't hear you because you're on the other side of a screen. That's supposed to be a 5. Okay, so now I'm going to factor 4 cosine from the left. So 4 cosine x. I'm left with, cosine x minus 1. And then on the right-hand binomial, I'm going to factor out a negative 5. And I'm left with cosine x minus 1. And all of that's equal to 0. And so now I'm going to factor this away from its term and the other one away from this term right here. And so I get cosine x minus 1. And what's left is in orange 4 cosine x minus 5 is equal to 0. I have independent factors set equal to 0. Well, I have factors set equal to 0, which makes them independent. And so I can solve this green guy by setting it equal to 0 and finding out when x is equal to 0. And so I get cosine x equals 1. There's only one value where cosine is equal to 1. That's that guy. So x is equal to 0 radians or degrees. And then over here on the right hand side with the orange, I got 4 cosine x minus 5 is equal to 0. I'm going to add 5 to both sides. I can already tell you it's not going to work. Divide both sides by 4. I get 5/4, and there's going to be no solution. Why? Well, go ahead and try to take the inverse. Since it's not one of our nice angles, it's not going to, you can't go to the unit circle, but try to take the inverse cosine of both sides. In other words, the inverse cosine of 5/4, and you'll get a domain error in your calculator because 5/4 is greater than 1. And remember, cosine of any angle can never end up giving us a number or value greater than 1 or less than negative 1. Unless there's a transformation, which there is not with that. So our solutions for this are x equals 0. Pow. That one's done.